I thought you'd like, oh, go back up. I thought you'd like this graph that I found. Always label your axis. If you don't label your axis, I'll chop off points. You get it? So we're going to actually now make graphs from our frequency tables. And I have the frequency table here with all the data filled out. And when you're creating a histogram from a frequency table, you always want to title the graph, label your axes, place the class boundaries on the horizontal axis. Now you can actually use class limits instead. Just make sure that you do 50, 60, 70, 80, 90, 100. And if you see questions from the outside world or on an AP test, this is really what you tend to see is the 50, 60, 70, 80, 90, 100. Today I'll show you the class boundaries. So place the frequencies or the relative frequencies on your vertical axis. So let's go ahead and make a graph. And make sure that one boundary it stops, the next one starts. So the bars need to touch. All right. So I'm going to go through this quickly because I know you can pause me. First, title it, label your axes. All right. We got frequency and we got score. These were test scores. My highest value is 12 and I have 6 here, so I can easily go up by 2. And then my boundaries on bottom. And the next part is pretty easy. I just start adding the bars in. 3 is the first one, then 5, then 12, then 9, then 8, then 2. Looking at relative frequency, instead of doing actual frequencies, I'm doing the percentage. And it's almost the same. In fact, the shape should look the same, or there's a problem. Now, since my highest frequency here is 30.8%, I go a little higher. I left that spot to go a little higher. And here we go. Put my boundaries on and put my bars in. So 7.7, it should be a little bit before 10. 12.8, 30.8, 23.1, 20.5. Now these are not exactly right. And no one's going to be saying, oh, your graph is just a teensy bit off. That's not the point. The point is to get a rough graph so you can see the shape and check it for some of the following. You need to be able to describe a histogram in terms of symmetry and modality. Symmetry is how much both sides are the same when we fold the graph in half. So if you take the left half and put it over the right or the right over the left, and how much they match, that's how symmetric they are. Now, if it's clearly not symmetric, then it's skewed. And then the other thing you need to tell me about is modality, which is a number of distinct peaks. One peak is unimodal, all right? So this distribution is mound-shaped because it is very symmetric. Left and right halves look the same, and it only has one peak. These two, on the other hand, are not symmetric. One of these is skewed left and one is skewed right. Now, most people, if I ask them, which one is this skewed, they want to say skewed right. Well, actually, the skew tends to be where the more unusual points are. So in this case, this one is skewed left. And over here, this one is skewed to the right. Mathematically, you're going to find out that when it's skewed left, what's going on is the average is getting pulled away from the median value to the left. And we'll go over that more. And here the average is getting pulled to the right. Now, if you want an easy mnemonic to remember which way is which, I picture these as the shadows of little mice. And I say, where's the tail? The tail is to the left on this one and to the right on that one. And that's one funky looking mouse. Anyway, so there are some other distributions you might see. This one is uniform or rectangular because the frequencies are almost the same. They don't have to be identical, but it looks like, oh, everything's pretty equal probability. That's called uniform, all right? And this one is called bimodal because it has 2 peaks. And this happens a lot when combining populations. So if I were to combine the populations in our class and measure the heights, I would probably get a distribution like this. Now the question is, what type of people would I normally get on this side? Well, who are the shortest people in your class? Are they mostly male or female? They tend to be mostly female. And then who are the tallest people in the class? They tend to be male. So you would get a peak for the average male height and a peak for the average female height. There'd be some mixing going on in here. And that's how you would get a bimodal distribution. Now here's some good news. The TI-84 is great at creating a histogram. So to do it, what you're going to do is you're going to enter your data in a list. So you're going to hit stat. I don't have these instructions here. Edit. And you can just start entering data points. Now, if you want to clear the list, you can go up here and press clear. All right. I'll enter some data points again. Now, these are not the data points I want. I'm going to use our Snapchats. So I'm going to go clear it again and then enter all the points that you see here. If I make a typo, it's not the end of the world because I'm just trying to show you a histogram. All right. But I think I got these pretty good. So once you finish entering the data points, we're going to basically go into the plot section. This is where stat plot is, and I'm almost done entering data points right here. There we go. Okay, so we need to go up here where it says stat plot. And here I'm just showing you, if you want to scoot over, you can see the beginning. So stat plot second, then stat plot. And choose enter. You want to make sure that's turned on. Then you're going to have to go over to the histogram. See, there's the histogram there. Make sure your other plots, once you hit enter here. All right, there's frequency is 1. You can change your list. You make sure your other plots are off. And you can press graph to do it and zoom 9 window stat. Now, if I want to change my window, I press window. And X min is the lowest value I want to use. 0 is fine. X max is the highest value. Actually, my let's see, 151, and I'm going, wait a second. I had like 730, so we'll do 750, and I'm going to use a class width of 150. So X max is the max, XCL is the bin width or the class width. You might see those two terms together. I think 23 is high enough for my highest data point. Press graph, and then you can press trace, and if you keep moving along there with the arrows, you can see the individual values. There you go. All right, so last thing we need to do is now make, an ogive. So an ogive shows what percentage of the data points occur at that class and lower. So you're going to title your graph, you're going to label your axes, you're going to use your class boundaries. I need to give myself more room here. Place relative frequencies on the vertical axis. And here's the weird part. You're going to place your starting dot at 0%. And then a dot for the class frequency goes over the next boundary. So this 7.7 is going to go over 59.5, and 0 is going to go over 49.5. Finally, you connect the dots with segments. So let me show you how this looks. So there's my labeling. I need to go all the way to 100% on a cumulative frequency because I better end at 100% or there's something wrong. Then there's my boundaries. Now remember, I'm not doing bars now, I'm doing dots. So I start with a dot, 0 at my lowest class boundary. Now I'm going to go to 7.7, which is about here. 20.5 is about there. 51.3 is roughly there. 74.4, that's closer to 80. And then finally 94.9, that's pretty close to 100. And then you always end at 100. Then you connect the dots with segments. And that is an ogive. So what's the point of an ogive? Basically, it lets you determine what frequencies are. And we'll do some examples very quickly with an ogive. Okay, now you can also interpret ogives. That's a cumulative frequency graph. We're not going to be able to answer all the questions I did on your notes because we haven't covered box and whisker plots. So, but we can do median because I know you learned median in middle school. Median is the halfway point. So at halfway up the count from 0 to 40, halfway up is 20. So I can go, okay, my median's going to be here, and it looks like that's about 7. All right. If you want to do the interquartile range, that will have to wait till after our next lesson. But the range we can figure out. My lowest value is 1. My highest value is 10. So my range appears to be 9. Here's another example for a different ogive. Now, notice the previous example. Let me go back. These are counts. You don't always have to have cumulative relative frequencies, but it usually is percentages to 100%. We'll pretend this one's 0 to 100%. That makes sense. If we want to approximate the median, the halfway point is at 50. So there's 50 going down, and it looks like it's kind of close to 0. What's your min? Negative 25, and your max is 25.